I can prove that two triangles are congruent by angle, side, angle, and angle, angle, side. Let's take a look at angle, side, angle first. Now we're not allowed to change either of these angles or that side. And if you look at these three examples, through inductive reasoning, I can see if I can't change these angles, all I can do is extend these sides. They have to meet the same way. I rotated these triangles, I flipped them, but they're all still the same triangle. Therefore, the three triangles share the same side, angle, and side, and are congruent. So the summary here is, did I say side, angle, side? Forgive me, angle, side, angle. Let's fix that. Angle, side, angle. So the summary here is you can only make one kind of triangle from angle, side, angle. Therefore, if two triangles have the same angle, side, angle, they must be congruent. Let's go ahead and check out angle, angle, side. Over here, notice again that this side is included between the two angles. Now though, over here, the side is not included between them. So this is a little bit different how we investigate this. We're not going to use inductive reasoning really. Now I can't change these two angles or that side. I can change this side here in between. I can change that side, I can change that angle. But if you take a look here, we're missing a third angle in either one. Do these third angles have to be the same? Well, let's use the triangle sum theorem. These have to sum up to 180. So 20 and 60 is 80, so this is going to have to be 100. 20 and 60 is 80, so this is going to have to be 100. Hey, what do you know? The two angles were congruent. So the missing third angles have to be congruent. If the interior angles will sum to 180. So we calculate them as both 100 and 100. And if you look really carefully, once we annotated those in, do you actually see what group we have? We do have angle, angle, side, but if we take this into account, it's really an angle, side, angle. So the interesting thing is, if you take a look up here, if you're given an angle, and a side, because you have two of the three angles, you can always go and find the third angle. And that's really important. You can always find the third angle. So if you're given angle, angle, side, you're really given angle, angle, side, angle, which is angle, side, angle. Why is that important? Because we just showed angle, side, angle worked. So angle, angle, side, because you can find the third angle, is really angle, side, angle. Therefore, angle, angle, side has to work as well, because it's really that one. So let's go ahead and summarize that really quickly. We actually have angle, angle, side with another angle, which is angle, side, angle. So the third angle theorem just says this. If you have two triangles, okay, if you have two angles, in one triangle congruent to two angles in another triangle, then their third angles must be congruent. They have to be congruent because they have to sum up to 180, the triangle sum theorem. So for angle, angle, side, what we're going to say is angle, angle, side is really angle, angle, side, and the other angle, or ASA, by the third angle theorem. ASA works, therefore angle, angle, side works to prove triangles congruent as well. Again, angle, angle, side is really angle, side, angle, because you can find that third angle. Therefore, because angle, side, angle works, and angle, angle, side is really this, then so does this work as well, angle, angle, side. Let's go ahead and apply this really quickly. No markings on this diagram, which means we have to provide them. Let's go ahead and put in, you can pause this and try it on your own first if you'd like. That's going to be the reflexive property. Going up here, segment BV bisects angles V and B. So here's angle V, bisects that. It also bisects angle V. Use two arcs. Make sure you do that. And the reason I could put this mark is, they didn't give it to me, but they told me I have a bisector. So that's the definition of a bisector. And that also works for this one here. So now I'm going to take the pink markings and I'm going to put them here in the congruency. I'm going to take the blue markings and put them over here in the Y. So here I go. My organization is going to be, oh, almost forgot, got to put my dots down on anything that doesn't have a marking. And you can see if you stay away from this, you really have an angle, side, and angle. So that's the group we're going to use. And I'm going to go with two arcs, one tick, one arc. That's an angle, side, angle. Let's go ahead now and write them in. So my two arcs, that's an angle EBV, is congruent to angle OBV. You have to use three letters here because this vertex is shared by more than one angle. Also, keep in mind the order. If we call this triangle 1 and this triangle 2, I have to follow that order now in how I make statements going down all the way to the very end. I could have gone in reverse, it didn't matter. Next up, segment BV is congruent to segment BV. And finally, angle EVB, I have to start up here in triangle 1 again. That's congruent to angle OVB. Let's talk about our reasons why. The reason why for the double arc is definition of a bisector, and also for the single arc. And it says here reflexive property for the single tick. So my statement, I'll say triangle EBV. I have to start up here in triangle 1 again, have to keep the order. It's congruent to angle OBV. And the reason why, by angle, side, angle. You can only make one kind of triangle with angle, side, angle. So because these two triangles share it, they must be congruent. Good luck.